Alright guys, our next topic here is graphs of speed, and so we've already talked a little bit about graphs of speed, but now we're going to talk about really what do those lines mean, what does the slope mean, and how we can describe these graphs better. Let's take a road trip. Suppose you travel between two cities that are 90 miles apart. You drive at 60 miles per hour for 1 hour, and so this is shown in your graph by this line, 60 miles per hour for 1 hour. Then you take a half-hour rest, so you're resting, and then you drive for another half hour at the same speed, 60 miles per hour. At the end, your friend calculates your speed to be only 45 miles per hour, so 90 miles divided by 2. So your total distance divided by your total time. Is your friend's calculation accurate? So 90 miles divided by 2 hours. Well, yes, they're correct. 90 over 2 is 45 miles per hour. But the thing with this is that they're calculating your average speed. Your average speed is your total distance divided by total time. If we want an instantaneous speed, at speed at any given moment, then this is best described, for example, when you are looking at your speedometer in your car. At that very instant, it tells you what your speed is. So if we're talking about speed and velocity, why are we working with a position time graph? So in physics, the word position refers to the location of an object at an instant. So for example, at 2 meters or at 3 meters, depending on where you are, that is your position. So speed is the rate at which the position of an object changes over time. So distance is related but different to position. So position time graphs are often called distance time graph because our distances can change as well the position that we are in. So how many stops does this boat make? So if we look at this graph and we know that it's a position time graph, we know that in this type of graph, a horizontal line represents stops. So I see 3 horizontal lines that means it made 3 stops. So what is the boat's average speed for the whole trip? So remember, average is the easiest. We take total distance. So here I can see that my total distance at the very end was 100 kilometers. And my total time is 10 hours. 10 hours. So 100 divided by 10 is 10 kilometers per hour. That's my average speed. So we find that we can determine the speed through the use of the slope on a position time graph or a distance time graph. So what does the slope of the graph really mean? So in order to find slope, and this is a review of what you might have seen in algebra, it is the ratio between rise over run, or the vertical change in your y-axis to your horizontal change on the x-axis. So for example, in this graph, our vertical change, or our rise, is 10. It's a unit of 10. And our run is also 10. So rise over run, rise divided by run, or 10 divided by 10 is 1. So our slope here is a unit of 1. So if we're looking at a position time graph, now we have units, we have seconds and meters. Then we see that our rise is our position, so it's 10 meters, divided by our run, our horizontal change in the x, which is 10 seconds. So 10 meters divided by 10 seconds is 1 meters per second. So the cool thing about this is that our slope tells us our speed. So if we can quickly find the slope of a graph for a position time graph, we can find the speed. So the slope of the distance time graph is speed. And straight lines mean that it's going at a constant speed. And the steeper the slope, the faster the speed. And this is very true because it's covering the same distance in a shorter amount of time. That means it's faster. And so this is what this graph shows. So let's talk about the 3 Little Pigs, a very memorable story from your childhood. So let's graph the wolf's path. So the wolf started from his house. So let's say we start here. This is our starting line. And he's traveled towards the straw house. Okay. And he stayed to blow it down. So he stayed. That means as time went by, he stayed at the house. And then he traveled to the stick house, so then he's walking, and again he stayed. So he stayed for a little bit. He blew it down in 8 seconds. Traveled to the brick house, died in the stew pot at the brick house. So once he died, he stayed there, and we keep going and going and going unless he gets moved. And so we see here that he made 3 stops. Horizontal line means that he stayed. So here is our precision time graph for the wolf and the 3 little pigs. So we see that it did stop at all 3 houses, and this is shown by a horizontal line. And we could also even, if we had numbers to go with position and time, we could even calculate his speed at each moment before going to each house, and through the use of the slope. Remember, this position time graph and the slope gives us the speed.